How will you address the challenges posed by emerging technologies such as artificial intelligence within the context of building services engineering?
How will I don't know.
Or we?
What is my view on it? Well, here you go. I'll use these notes to guide me through it a little bit, if that's okay, because it's I think we do need to get even more innovative about the way that we design our buildings, but we know that the industry is moving more progressively towards modular construction and process management systems, so BIM, building information modeling, digital information modeling, data exchange. And I think we need to embrace it. It's in the same way, you know, a generation ago, CAD transformed the role, didn't it, of building designers. Now BIM and digitalisation is slowly doing so again. Yet a lot of us are struggling to collaborate and exchange data within the same database and computer model, and we're not allowing ourselves enough time. You know, you mentioned programs for testing and commissioning. Well, you look at a design program and they're not allowing time for it to be BIM. Certainly not. And again, going back to a traditional building construction program or design program, it's like it isn't collaborative. It's like the first bar says that the architect's going to develop you know, stage 3 design, and then we're going to, and it all follows one after the other. It has these little overlaps, but we need to be building time. And if they want us to, another little soapbox is, you know, everyone personally, actually it's slightly radical, but everyone benefits from BIM, apart from poor old building services engineer. Gets a shed load more work to do because he's got to design it in the third. You know, the difference between drawing, you know, two pipes or a ductwork in 2D, you draw your lines. There's about 4 lines involved, isn't there? And then when you're drawing it in 3D, it's a huge amount of additional work. Yet who benefits from that? I mean, being a little bit controversial, of course, that then makes it really easy for the architect to do his coordination, because he hasn't got to look at our drawing and then go across and look at structure. This is all in the model. Anyway, yes, so moving on. So we struggle on that, but I do think we need to spend sufficient time to understand how to use the software properly, so that we get, you know, building services engineers, as opposed to just being, you know, dragged through it and then it changes and we have to design it and all that sort of stuff. So I think we need to tear up for that. We at CIBSE led the introduction, or our own digital society, the Society of Digital Engineers, led the introduction of product data templates, which enabled us to it enabled manufacturers to give us the right information in the right format to promote better integration in the model. If you think about, you know, is that all the manufacturers were coming up and saying that there's our information there, the product data templates, and we said, well, no, just give us the key information we want. This is what we want next year. So they're using that format, which is good. It's done inside Revit and other tools at the moment. So, but I do. You mentioned, I think, Jeff, you mentioned in SPONS and the embodied carbon. Yeah, I can see embodied carbon and building safety for I can see them going in the BIM model. Yeah. And fairly new, because it's, if you think, if you've got a BIM model, I mean, technically with the BIM model, you can get all the way, once you've got to your Kobe outputs, you can generate an entire material schedule, can't you? So technically, I'm not sure they ever would, but technically you can press a button and give it to a builder's merchant and say, give me everything I need to build that building. So it's an easy thing to say, embodied carbon associated with that, add the whole lot up, you got the embodied carbon for the building. So I can see that going in. And we do need to embrace, which is a tough one for us, but we do need to embrace prefabrication and off-site construction. For us, it's a key drivers probably a plant room, isn't it? If you can take a set of, say, 6 pumps, for example, put them on a frame in a factory, and then deliver everything together, you drastically reduce the room for the margin of error, and you reduce the health and safety risk to the installer. So whether we like it or not, and I think most of us probably don't, it has to be the future, high quality precision engineering, when it's constructed, tested, and often sometimes even commissioned in a factory environment. So it's here, the contractors are using it, we might as well embrace it and try and contribute to that. And then you get to yours. So we've got real-time analytics, which is for project management, for testing and commissioning and defects resolution. We've got RTS mapping now, haven't we, for mapping existing installations. We've got cloud computing, digital twins, digital as-builts, and then you get to AI. Where does that fit in? We were looking at our master specs, and funny enough, it came up in Scotland as well. So an obvious place there is that you do chatbots or chat GPT, if you're wanting to add, what are the latest British, give me a list of the latest British standards or design guidance for, which is what we all struggle to keep on. You just do a review of your master specs, and 2 minutes later somebody's come out with it. How do you track all that? So there's a role for that, but it's digital acceleration is happening so much faster than anyone ever anticipated. We've got to give it sufficient time to understand it and incorporate it into our day-to-day activities where it's appropriate to do so. So